Hi guys, this is lesson 3 in unit 5. We're going to talk about features of functions. Now let's find out what kind of features should we expect when we talk about functions. Intercepts. We have the x-intercepts and the y-intercept. The x-intercepts are also called zeros, and the y-intercept is called the initial value. Second feature are the extrema. When we talk about the extrema, we talked about the maxima and the minima. The maxima when we have more than one maximum, and minima when we have more than one minimum value. Intervals. We have 4 kinds of intervals that we talk about when we look at functions. An increasing interval, a decreasing interval, a positive interval, and a negative interval. And remember that when we talk about intervals, we're talking about x values. We're talking about values on the x-axis. Let's talk about the intercepts first. We have 2 kinds of intercepts. We said we have the initial value of a function, which is the y-intercept. This is the first value in the first quadrant where we have positive x and y values. And if we look at this graph, we'll find out that the y-intercept in this case is this point, and this point on the y-axis is where the graph crosses the y-axis, and this point is 0, 2, which means that the y-intercept, or the initial value for this graph, is 2. The zeros of the function are the x-intercepts. And if we look at the graph here, we'll find out that we have 3 x-intercepts where the graph crosses the x-axis. This is one of these points. That's the second 0. And this is the third 0. This point is -1, 0. This point is 4, 0. And this point is 7, 0. Which means that the zeros for this function or this graph are -1, 4, and 7. Now let's look at the extrema for this function. I'm going to talk about the extrema for this function over an interval. I'm going to look at the interval between all the x values between -1 and 8. Which means I'm gonna look at that graph starting at this value and ending here. So let's do that. Let's talk about the maximum first. The maximum is the greatest output, f of x or y, value for a function. So if we look at the y-axis and look at the greatest output or y value that we have for this graph over the interval that we have in here, we'll find out that this point right here is the maximum of this function. This is the maximum value, and the maximum value is how high can the function go. And in this case, the height for this function on the y value is 4. So the maximum value for this graph over this interval is 4. The minimum value over a function is the least output f of x value or y value that you see on this graph. So in this case, the least y value that we have on this graph belongs to this point, which is the lowest point of the graph. And the minimum is basically how low this point is going, and in this case, the y value for this point is -2. That means that the minimum value for this function is -2. So the maximum is 4, and the minimum in this case is -2. Now let's talk about intervals, and let's talk about what kind of intervals we can identify looking at a graph. The first interval that I'm going to talk about is an increasing interval. And an increasing interval means that the output values of a function increase as the input values increase. What does that mean? It means that we are trying to look for that part of the graph where the values of the y increases as we go from the left to the right on the graph. That means as I go from the left to the right, I see that my y values here at that part increase. And I see that it starts to go down after that, and it goes up again at the last part. So these two pieces of the graph represent increasing intervals. Now, when I write an increasing interval, I don't need to include any endpoints. So when we write an increasing interval or any kind of interval, we'll exclude the endpoints for the maximum and the minimum value. So to write an increasing interval here, I can say that, let me just take this out. I can say that as the x values go from -infinity to 1 right here, which means this part, not including 1, this is an increasing interval. The values are going up. Another increasing interval is 5 to 8. So as my x values become greater than 5 and less than 8, my function is increasing, and these values are represented here on the graph. And as you can see, we see an increase in the y values for all the x values between 5 and 8. So these two intervals that we have here are two increasing intervals. Now, let's talk about a decreasing interval. A decreasing interval is the opposite. The output values decrease as the input values increase. So in this case, if I look at the graph, I find out that my values here at that part of the graph decrease, my y values decrease as my x values increase. So again, I can write an interval for all the x values between 1 and 5, not including 1, since we have a peak here, and not including 5, since this is the lowest point. So all these x values between 1 and 5 represent a decreasing intervals, because as the x values between 1 to 5 increases, the y values decrease. Now let's talk about a positive interval, which is an interval that includes x values that have y values greater or equal to 0. So that means the y values here has to be greater or equal to 0. So if we look at the graph, we'll find out that this part of the graph includes positive y values. All these points has positive y values. And this piece right here at the end is also a piece that has positive y values. So if I'm going to write an interval for which f of x is greater or equal to 0, that means I'm going to include every single point or every single x value that belong to these two parts. So I can write down an interval from -1 here, since -1 has a y value of 0, to 4, since again 4 has a y value of 0. So my first interval, and this interval is one of many intervals, can be an interval from -1 to 4, or we can write it down as every single x greater or equal to -1, less than or equal to 4. And we have another interval, which is from 7 to 8. So all the x values between between 7, including 7, and less than 8, including 8, include x values that has y positive values. Now let's talk about a negative interval, where the y value or f of x value is less than 0. So again, let's take a look at the graph. We'll find out that the graph include parts where the y values are negative, and these pieces, this is the first one, and this is the second one, and this is the third one. These pieces include points where the y values are negative. So again, we can write so many intervals that belong to these three pieces, but remember, we cannot include the points on the x-axis because these points has a y value of 0, which is not less than 0. So I can write an interval that goes from -infinity to 2, not including 2, because all the x values between -infinity and 2 have y value or negative y values. Another interval is from 4 to 7, and in this interval we'll see that we have x values between 4 and 7, not including 4 and 7, that have negative y values.